Hello, and this is checkpoint 4.27. They want us to find the derivative of y with respect to x, where y is defined implicitly by this function, x squared plus xy minus y squared plus 7x minus 3y minus 26 is equal to 0. After we find the derivative, they want us to find a tangent line at a point 3 comma negative 2. So back in differential calculus, we took the derivative of this by taking the derivative implicitly, where we would take the derivative of x regularly, but anything with a y in it, we would use a chain rule and tack on a y prime. And after we do that, we gather all the y primes together on one side. We'll take all the x's over to the other side. So essentially the derivative with respect to x goes to the other side. And then we would factor out the y prime and divide by all that stuff that we took when we took the derivative with respect to y. So if you can try to remember that process, you can kind of summarize it by saying y prime, or dy dx, is equal to all those derivatives that we took. So if we consider this whole thing as a function of x and y, then all those derivatives that we took with respect to x, we brought over to the other side, so there's a negative sign, and then we take the derivative with respect to y and factor out all the y primes, and we would divide by whatever we had as a result. And now you have a nice, neat formula for implicit differentiation once we know a little something about partial derivatives. Okay, so it looks like that's what we need to do. We need to find the partial of f with respect to x. So let's find the partial of f with respect to x. And that's going to be 2x plus y, nothing, and 7. And then the partial of f with respect to y is going to be x minus 2y minus 3, and that's your derivative. So if we wanted to find dy dx, it's going to be the negative of 2x plus y plus 7 divided by x minus 2y minus 3. Okay, so that's the derivative. Now we want to take it some steps farther and find out what happens at the point 3, negative 2. So if we want to find the tangent line, this, by the way, is an implicit curve. It's a curve on the xy plane, and it looks like we have an x squared and a negative y squared, so this is probably going to be a hyperbola of some sort, and there's extra terms with an xy in it, so it's probably going to be a hyperbola that's been kind of rotated. And at this point, there's going to be a tangent line. So what we need for an equation of a line is we need the point and a slope, and this is a two-dimensional line, so just the point and the slope. And the slope will be given to us by figuring out the derivative, which we did, and evaluating this at 3, negative 2. X is equal to 3 and y is equal to negative 2. So we have a negative sign. Let's put a 3 in for x, 2 times 3, and a negative 2 in for y. And then here we do the same thing, 3 in for x, negative 2 in for y. And what do we get? We're going to get 6. 6 minus 2 is 4, plus 7 is 11, divided by, and then here we have a 3, minus 3 is 0, so that leaves a middle term, positive 4. And a negative sign in front keeps that all negative, so negative 11/4. And we simply use, I'll stick with the point slope formula, y minus y1, so that's y minus negative 2 is equal to the slope, negative 11/4 x minus 3. Okay, and that should be it. If you were to draw this in Desmos, you can draw that graph, you can plot this point, you can draw this line, you'll see that it will in fact be tangent. Okay, I hope that helps.